Today we are going to talk about the metal tin, Sm. Tin is in the fifth period of the periodic table, the fourth group. The metal was known as early as the 4th century BC, but it was difficult to refine, so the price was higher. During the Bronze Age, tin was used as a strategic metal because tin-containing bronze was much stronger than pure copper. Tin is derived from minerals such as tin and sulfur. Tin is a lustrous soft metal, covered by oxides of tin, slightly yellowish, less dense than lead, with the melting point of 231.89 degrees. Its low melting point makes it easy to melt into various shapes, and it is not as toxic as lead. If you bend a very pure tin ingot, you can hear the sound of the crystal inside the metal deforming. The same properties can be found in indium and zinc. Compared to other metals, tin has a uniqueness called polymorphism. This kind of tin is called white tin, and if white tin is put in a cold environment of less than 15 degrees, then white tin will start to turn into a gray form, which is gray tin. The transformation process can be observed from video. Gray tin has a completely different crystal structure from white tin, similar to diamond. Any product made of white tin will be brittle if this transformation takes place. This effect is also known as tin plague. From a chemical point of view, tin is a low reactive metal that reacts slowly with dilute acids. In aqua regia, tin dissolves quickly and forms tin tetrachloride. When heated to more than 150 degrees, tin begins to oxidize gradually in the air, and when heated to 1000 degrees, tin burns in the air to form tin dioxide. Tin dichloride is the most common of the tin compounds. You can do a couple of interesting experiments with it. Dissolving tin dichloride in 10% sulfuric acid to prevent its hydrolysis, then pouring the solution into the Petri dish. Attaching the electrode to the edge of the Petri dish, you will see tin chloride is oxidized to tin dioxide at the anode. Tin crystals look beautiful in macro photography. If the polarity is reversed, the new tin crystal dissolves and the new crystal precipitates at the cathode with a negative electrode. This reduction process is used in the production of tin cans. Adding a sheet of zinc to a solution of tin dichloride and it will be covered with beautiful tin crystals. In this reaction, the zinc is oxidized to zinc chloride, and the tin is reduced to its metallic form, which makes a beautiful tin hedgehog. At present, tin is mainly used as safe, non-toxic, corrosion-resistant coating of pure alloy or other metal alloy. In everyday life, we can find tin in solder, which is mixed with other metals, mainly lead. Tin's most important alloy is copper, which is bronze. At the same time, tin is also an important part of titanium alloy. Tin disulfide, commonly known as gold powder, is used in paint to imitate gold plating. In recent years, there has been a major problem with the introduction of lead-free solders into electronics, which produce long, thin tin crystals, also known as tin whiskers. These tin whiskers can grow very long, causing short circuits and equipment failures. The phenomenon, which has led to the breakdown of many electronic systems and even the paralysis of some orbiting satellites, remains unclear. But whiskers can be prevented by adding antimony or other low-melting metals to solder.